Chapter 11 is going to be on solving quadratic equations. And so when we say a quadratic equation, we're talking about a polynomial equation of degree 2, ax squared plus bx plus c equals 0. That would be in a kind of a simplified form. Now, we've already learned one technique, which is to try to factor. And so that's always a good technique, but not everything factors. So this chapter is going to be the first couple of sections here. We're going to develop a couple of different techniques to solve these degree 2 equations when potentially it doesn't factor. So the first thing we're going to talk about in this video is the first objective on using the square root property to solve quadratic equations. So let's think about, we're going to need to recall here from the last chapter, if x can be any real number, meaning positive or negative. So I want you to recall from the last chapter, chapter 10, it was one of maybe the earlier sections, 10.2 maybe. We developed this idea that, yes, the square root of 3 squared gives us root 9, which is 3. But then when we take the square root of negative 3 squared, so if the x can be negative, that is also square root of 9, which is equal to, again, 3, not negative 3. So we kind of use these observations to say, oh, so that's going to mean if I am taking the square root of an x that could be positive or negative, I need to, yes, realize these two operations are kind of undoing each other, but we're going to get back to the positive version of that x. So we said that is technically equal to the absolute value of x when x can be positive or negative. And certainly when we're solving equations, we're going to be interested in any solution, positive or negative. X will have the potential to be negative. Now we want to remember, so now let's recall back from our chapter on absolute value, that if I said solve the equation, let's say absolute value of x equals 7, so for some positive number like 7, we said that would be satisfied if x was equal to either positive or negative 7. So if absolute value of x is equal to some positive a, then x could either be plus or minus a. So when we kind of look at these two facts together, we're going to look at one example where we're going to kind of show all of this work, and then we'll develop sort of our shortcut shorthand for it. So if I have an equation that is x squared equals 9, and I am trying to solve for x. Now certainly this is an example of one that if I wanted to subtract the 9 over, this actually would factor. But it is nice if there's only an x squared term and there's not like an x term. This is a nice thing to be able to do, which is just to take the square root. So I'm doing the same thing to both sides. That's one of our fundamental big ideas in algebra. I can do whatever I want to an equation as long as I'm doing it the same to both sides. So we just said from up above, when x can be positive or negative, the square root of x squared is equal to the absolute value of x. And on the right, when I take the radical, the principal or the positive square root of 9 is 3. And then absolute value equation, absolute value of x equals 3, means x is equal to either plus or minus 3. And so that would be our solution. Now, we don't want to do this every time. Okay? The same thing would happen every time we were taking a square root. We would get the absolute value, and then we would have to introduce the plus or minus. So essentially what we do is we pull these facts together, and we're just going to say, let's just observe that this is always going to happen. And so what we're going to do is we are going to develop this kind of square root principle or square root property, which is basically going to say this. If I am solving an equation, and obviously x having the potential to be positive or negative, and if I introduce the square root to get rid of a square, I'm going to skip the middle step, and I'm just going to introduce the plus or minus with that square root. So what we get then is x is equal to both the plus and minus 3. So we're just going to kind of make this observation this one time. And so now what we're going to say is putting these facts together. And again, this is what is called, and when you see it in the homework, so putting these facts together, what we have is something that's going to be referred to as the square root, either principle or sometimes property, for solving a degree 2 equation. Hang on just a second. I'm going to turn that off. I'm sorry if you heard my phone ring there. I just want to turn it off. But we're just going to end with summarizing what this square root principle or property is, which is really just saying what I said up above. If you introduce a square root in an equation to get rid of the square, then you have to introduce the plus or minus square root on the other side. So that's what we were doing right up here. If I'm introducing the square root to get rid of the square, then I have to know to introduce the plus or minus square root. So let's look at maybe just one more example here in this first video. So suppose I have x squared minus 48 is equal to 0. So I would want to first recognize I just have an x squared term. That's it. There's no x term. And when the x is just in one location, I think a lot of our intuition serves us well, which is just this idea of isolating and kind of working our way into the x. So that's exactly what we now know how to do properly. So we add the 48 to the other side, and now here's the square root principle. If I'm introducing the square root to get rid of the square, I have to know to introduce the plus or minus square root on the other side. So again, this is our square root principle. When I introduce that square root to get rid of the square, I have to know to introduce that plus or minus square root. And so what we get here, and now that we've talked about in the last chapter simplifying radicals, we're going to always expect that you simplify radicals. So here the largest perfect square factor of 48 would be 16. So this is like root 16 times root 3. And so what we get is both plus and minus 4 times the square root of 3. A lot of time, I mean, I would be fine with this, like on a quiz or a test. A lot of times in your homework, they may ask you to kind of write out the solutions, and if there's more than one, just kind of separated by a comma like that. Okay, so this is the square root principle. So when we come back next time, we're going to look at more examples. We're going to get some imaginary complex solutions, and then we're also going to see sort of some additional steps, but that all involve using this square root principle.